We'll take one more 10-minute break before we break for lunch. So in about an hour or so, we'll take another 10-minute break. Okay, when we took our break, we were talking about our service equipment. And we've got just a few more slides on that, and then we'll get into another subject. But when it comes time to size our service entrance conductors, we can use E3603.1, which is 31015B7 in the National Electrical Code, and we can apply a derating factor to those conductors, and the code permits us to use a 83% load calculation on the standard ampacity ratings. And the service conductors for a dwelling unit, we can use a little bit smaller size because of that 83% load calculation than we normally would be able to use. In other words, let's say you have a 200 amp meter base or a 200 amp service disconnected means, a 200 amp panel board with a 200 amp main in it. So what we have to do is we have to install some service entrance conductors that are equal to or greater than that 200 amp rating right there. And so if you went to your standard ampacity table, you know, at 31016 in the National Electrical Code, E370, I can't remember the E370.5.1, I believe it is, in the IRC, you would have to use like a 3/0. In other words, a 2/0 copper conductor, even in the 90-degree ampacity rating or column, would be good for only 195 amperes. So the code, if we were using strictly the standard ampacity table, would tell us that we would need 3/0, a 3/0 copper conductor for that 200 amp rated service. But when we apply this 83% load calculation that the code permits us to use, then we can actually use 2/0 copper for the service entrance conductors at a dwelling unit, whereas if we were at a strip shopping center, a commercial shopping center or something, that same 200 amp service would have to be, we'd have to use 3/0 for that 200 amp service. All of that is based on diversity loads at dwelling units. In other words, you know, how many times do you use all 4 burners on your range top? Now, I've got a branch circuit supplied to that range top that if you want to run all 4 burners, be my guest, but how many times do you actually do that? At the same time you're doing that, you're running the oven. You're running every exhaust fan in the house. You're running the heat and the air at the same time, which is, you know, virtually impossible. But because of those diversity loads, that's why we're able to use that 83% load calculation at dwelling units. And we can use those smaller sizes or that 83% reduction or load calculation to size. Let me get my pointer back up here. To size those conductors right there. Now, we can also use it on one feeder in the dwelling unit. And the reason I say 1 feeder is because the code says that we can use that 83% load calculation on a feeder if it supplies the entire dwelling unit, every load in the dwelling unit. So if it has to supply power to the entire dwelling unit, how could it be more than 1? So if that feeder right there, in other words, if every load in the dwelling unit came out of that panel board right there, then we could use this same 83% reduction to size that feeder as well. But now in this case, as you can clearly see, that feeder does not supply power to the entire dwelling unit, so we wouldn't be able to use that 83% load calculation on that feeder to size that feeder right there. We would just size it based on the loads associated with that feeder panel board right there. Now, in no case does that feeder right there have to be larger than the service entrance conductors. Now, we've got our service coming in. We've got a disconnecting means right here. First means disconnect. We've got a feeder coming over here to a feeder panel board, and every load in the dwelling unit does come out of that feeder panel board right there. So in this case, we could use the E3603.1 31015B7 out of the National Electrical Code with that 83% load calculation there to size these conductors right here and that feeder conductor right there, because again, that feeder supplies the entire load of the dwelling unit. There's an informational note in the back of the National Electrical Code at Annex D that gives you an example of how to use that 83% load calculation. And it even gives us, there's 2 examples back there actually. One, if we have to do a correction factor, one with no correction factor whatsoever. In other words, we don't have to deduct for number of current carrying conductors in a raceway or a temperature adjustment correction factor or something like that. And then we have an example to where we do have to do a temperature correction factor and how to use that 83% load calculation with that at the same time while we're having to do a temperature correction factor as well. And interesting enough, in the NEC, back there at those informational notes, you'll see a little table that gives us some sizes. This table used to be part of the code book, and it got removed in the 2014 NEC, 2015 IRC, and then the very next edition it showed back up, but it's in an annex in the NEC, so it's not enforceable. But for the 2020 code, it has returned the 2021 IRC, and I think I have a slide coming up on that. We have to have a circuit directory for our panel boards that contain overcurrent devices and so on. And it has to be legible, and it has to have an approved degree of detail. Now, if you look in Chapter 35 of the IRC or Article 100 in the NEC, the term approved is a defined term. And what's the definition of approved? Approved means what? Acceptable to who? The authority having jurisdiction. So the local inspector, the local AHJ would have to approve the degree of detail. In other words, can I just put bedroom, bedroom, bedroom? Is that enough detail? If I were the authority having jurisdiction, no, it would not be. And our identification of our circuits here It cannot depend on transient conditions of occupancy. Those are big fancy words right there. What that means is you can't say this circuit breaker here, it provides power to Jody's room or Fred's room. Well, Fred moved out about 3 years ago and we hadn't seen him since. So you can't say something that depends on transient conditions of occupancy. In other words, rather than saying Fred's room, this controls Fred's bedroom, you would say this circuit breaker right here controls the northeast corner bedroom. And that would get away from those transient conditions of occupancy for our detail on our circuit directory.
Hey Keith, quick question.
Okay, just for 1 second. Would you take this right here as the AHJ?
Where it says master front?
I think that's enough detail that I would take that as a approved degree of detail on my circuit directory. Go ahead.
Quick question. So on the slide that you have right now, do you actually check to see if they're marked correctly? And the reason I ask is because I just moved into my boyfriend's house. We did taking a dishwasher from Hardwired and put an outlet in, turned off them as they were labeled by the contractor who upgraded the service, and they were not labeled correctly, and my brother got zapped.
No, I would, as the inspector, that's, in my opinion, that's part of my job, is to make sure that it's properly labeled. Now, some jurisdictions will, when they come out to do electrical final, they require that the power be on the dwelling unit before they'll make an inspection. Some of them even require the electrical final is all about getting the meter set, and so some of them will even say, by local ordinance, will say you need to temporarily hot the house, supply power to the house with a temporary line from the temporary pole, so that I can do just what you're talking about. So yes, I would say that that's part of the job of the AHJ. Now, I will say this, as the local inspector, you get familiar with your local contractors, and there were situations to where I could trust this installer. I knew he was going to do his job properly, and I didn't have it, I didn't just have to 1, 2, 3 check every single circuit, whereas others, it might not be that I don't trust them, I just don't know them. And so yes, I would check the detail, and are these actually going to where you're saying they're going? And again, yes, I think that's part of your job as the inspector.
Thank you.
When it comes to our circuit directory, there's a change in the next edition of the code you probably need to be aware of. We're starting to run out of real estate on the panel board lids and things like that, because we're having to have so many labels lately on the lid of a panel board, that for the upcoming code, you still have to have your circuits identified. You have to have a circuit directory. It has to be located on the face or inside of the panel board lid. But coming, it says, or in an approved, who does approving, in an approved location adjacent to the panel board door. I also do our analysis of changes for each edition of the code. And so I made a guess as to what that might look like, an approved location adjacent to the panel board door. And I thought about perhaps maybe a notebook where you could put a whole lot more detail in this notebook than you could on this panel board lid circuit directory. And I'm going to get a little chain and just chain it to the panel board lid, with a screw or something there. Now, all of that's great, but who's got to approve this? Authority having jurisdiction. So before I even tried something like this, if I were the installer, when we get to the next edition of the code, before I even tried something like this, where's my first phone call going to be? The ASJ and say, hey, code says I can now put my circuit directory in a location adjacent to the panel board as long as it's approved. Would you approve me with a doing something like this? And if the ASJ said, yeah, I'll approve that, then you're good to go. We also have to have barriers. This hadn't been a requirement in the code for too long, maybe one or two code cycles, but we have to have barriers in service panel boards that will barrier off any live exposed parts. In other words, this is a typical panel board that you would find at a dwelling unit with a main right here. And when I turn that main off, I have no live exposed parts below that main. The only two live exposed parts in this panel board would be those two lugs right there where my service conductors are coming in and terminating onto these two lugs right here. So, like right here, to make this code compliant right here, I would just need to barrier off that lug right there and that lug right there. Now, again, if we provide the manufacturers an opportunity to build a better mousetrap, don't they typically do it? And every manufacturer of panel boards, your Siemens, your GE, Color Hammer, all of those are now providing these little rubber boots, plastic boots that can just slip right over these lugs right here and meet this code requirement. For the 2020 NEC, this in the 2018 IRC 2017 NEC, this requirement was located in Article 408 for panel boards in the National Electrical Code. In the 20 code, that was moved to Article 230 so that it would apply to all types of service equipment, not just the panel board. And this is one of those places in the code where you would have to default to the NEC. The IRC does not address these barrier requirements for barriering off any live exposed parts in a panel board. So again, back there in chapter 34 in the scope of the IRC, remember what it tells us back there. Just because it's not covered in the IRC, we can't just ignore it. We have to comply. We have to default to the National Electrical Code on something like this that's not covered in the IRC. You're going to have a main bonding jumper in your service equipment. The main bonding jumper is a defined term, and it actually is the connection between the grounded conductor, the intentionally grounded conductor, your grounding electrode conductors, and your equipment grounding conductors at service equipment. Now, typically, you're going to be using listed equipment. You're going to be seeing listed equipment, such as a listed panel board. And typically, the manufacturer is going to provide the main bonding jumper for this particular panel board. It's going to be sized per the rating of this panel board already. In other words, you don't have to Not very often at all do you have to get into sizing a main bonding jumper yourself. They're typically provided by the manufacturer of listed equipment, and you just need to make sure it gets installed properly. Now, main bonding jumper can take the form of a wire. Very seldom do you see this, particularly at dwelling units, or it could be in the form of a strap. You see that a lot at a dwelling unit, or it can be in the form of a screw. Now, if it is in the form of that screw, then that screw has to have a green color finish, and that has to be green from the manufacturer, not green from the installer getting the green marks a lot and painting the head of that screw green. That would come directly from the manufacturer. Something like that right there. In this case, the main bonding jumper is actually in the form of a strap with that screw connecting it to the metal cabinet of this particular panel board right here. We have to provide overcurrent protection for panel boards, and a lot of times at dwelling units, the panel board is, the first means of disconnect as well. Typically, the code is going to call for one at a panel board. It's going to call for one main means of disconnect located at the panel board location. There are several exceptions to that rule. Exception number 1 tells us that we can have individual protection provided to the panel board from a external means of disconnect, and we can actually have up to 6 means of disconnect. Another exception says that we can have it on the supply side. In other words, remember that disconnect we saw this morning located on the outside of the building, and we were going to run a feeder from that outside location to a location perhaps in the garage or something. That would be exception number 2 right here. And exception number 3 talks about existing panel boards not having to have individual overcurrent protection at an existing panel board at an existing residential occupancy. And what that would cover is the old split boat or split bus type panel boards that we used to see. That those are no longer legal, but there are hundreds, thousands of them out there, and so the code does recognize them and gives us an exception for those type of older type panel boards. But for the most part, you're looking at having to have a main either located directly in the panel board itself or fed from on the supply side to that main lug only panel board, like in a garage or something like that. You're typically limited to 42 overcurrent devices. In other words, 42 throws of the hand. Now there are panel boards that are designed and listed and identified for more than 42 overcurrent devices, but you would rarely see those in a dwelling unit. Something like this right here that is identified for 60 overcurrent devices, listed and identified for 60 overcurrent devices. But it would be not impossible, but it would be unusual to see this at a dwelling unit. This is typically a commercial application. Here's the that exception number 1 that we talked about, where, and you would have a label on this one saying suitable for use as service equipment, where you have not more than 6 means of disconnect right here. And here's an actual photo of something like that. That would be code compliant with no more than 6 throws of the hand right here. This is new for the next edition of the code, and I wanted to make you aware of it here. We are permitted to have more than one means of disconnect. Matter of fact, the code tells us we can have up to 6 means of disconnect. In previous editions of the code, we could locate those 6 means of disconnect either in one enclosure or in 6 separate enclosures. Now, if they're in separate enclosures, they have to be grouped together. Now, again, there you go. There's another gray area. What does grouped in this particular location here? What does group mean? That's going to be up to the authority having jurisdiction to determine what group means there, but they do have to be grouped together if they're in individual disconnected means. For the 2021 IRC, the 2020 NEC, you can still have up to 6 means of disconnect, but they cannot be located in a single enclosure. If you have more than one means of disconnect, they have to be located in separate enclosures once you get to the next edition of the code. Now, if you're enforcing the 2017 NEC, 2018 IRC, then this rule doesn't apply. I just wanted to give you a heads up that this is coming for the next edition of the code. This all has to do with that barrier requirement that we saw a while ago. When you have more than one means of disconnect in a single enclosure, it's impossible to barrier off all of the live exposed parts. And so to go along with that barrier requirement for the next edition of the code, again, your ability to have more than one means of disconnect and have those located in the same enclosure has been eliminated. Again, you can still have more than one means of disconnect, but if you do, in the next edition of the code, they would have to be located in separate enclosures like you see here. Another change that's coming in the next edition of the code is a requirement for an exterior and outdoor emergency disconnect at all dwelling units. This is a pretty big change coming in the code. And again, I wanted to just make you aware of it. Has to be installed in a readily accessible location outdoors. This was a change brought on by the firefighting community, first responders. And they detailed how extremely dangerous and difficult it was to put their personnel in danger of having to enter a building, particularly in a fire situation, enter a building to turn power off. Gosh, I don't know, most jurisdictions, the one I live in here, you know, if you had a fire at a building, particularly a dwelling unit, you wouldn't have to worry about whether the disconnect was outside, inside, or what, because the utility company is going to turn the power off at the pole. Maybe even knock off, you know, your neighbor's power while the firefighters fight that fire there. But again, I just wanted to make you aware of this, that coming for the 2021 IRC, 2020 NEC, that you do have an outdoor emergency disconnect requirement. In other words, your first means of disconnect, for the most part, is going to have to be located outdoors. You got 3 options here. You could locate your service disconnect outside, and in that case, you would have to put a label on it, like this right here. This is my emergency disconnect right here. This is my emergency disconnect, but it's also my service disconnect. Or you could put an emergency disconnect outside and still have your service disconnect inside. And if you did that, you would have to put a label like this: emergency disconnect, yes, not my service disconnect. In other words, my service disconnect is still inside somewhere. You can also use a meter disconnect. If that meter disconnect is rated for the entire load of that dwelling unit, which some of them are and some of them aren't. So you'd have to look at that. In that case, you would put a label on it saying, yes, this is my emergency disconnect. Yes, it is a meter disconnect, but it is not my service disconnect. My service disconnect is still located inside somewhere.
Keith, just a quick question on that. I realize this isn't going to happen until next year, but did they think of security, like in-house invasion and somebody tripping all the power?
Yeah, it can. I mean, the rules are still in place that says that your service disconnects and so on can be lockable as long as the occupant has access to that lockable disconnect.
Oh,
yes.
So the firefighter just cut the lock off, is what you're saying? Yeah. Okay, got it.
Yeah.
Thank you.
This is what we were talking about a while ago. Yeah, you know, at our first means of disconnect, you're going to have to you have to tie your grounds and neutrals together at your first means of disconnect. But once you get past your first means of disconnect, and in this particular case right here, that's my first means of disconnect right here. In other words, here's service entrance conductors right here. And I'm gonna set a main right here. And this is service right here, but what is this right here? This is a feeder right here with overcurrent protection ahead of that feeder. But once I get past this first means of disconnect, I've got to isolate or float my grounded conductors from my grounding conductors. Past that first means of disconnect, particularly in a 120 volt branch circuit, your neutral conductor, your intentionally grounded conductor are going to be current carrying conductors. In other words, let's say I have a ceiling fan in the ceiling of a den or something. And that ceiling fan draws 3.8 amps of current. So I've got a hot conductor going up to that ceiling fan, and then I have a neutral conductor, a grounded conductor coming back. And to make that fan turn, I'm going to have 3.8 amps of current flowing on that hot conductor going up. How much current am I going to have coming back on that neutral conductor? 3.8 amps of current. You're going to have the same amount of current. So once you get past this first means of now at the first means of disconnect, you're going to establish a grounding electrode system, and it would bleed off any circulating currents at that point. But past that first means of disconnect, if I were to tie my grounds and neutrals together, then any current that's flowing on these grounded conductors, I just introduced them onto my equipment grounding conductors, and that's when you get, if you've ever been to a dwelling unit or something and you reach out and you touch the lid of a panel board and you get a tingling sensation, I can almost guarantee you that's what's going on there. Is the installer, the electrician, Harry the handyman, or somebody has tied grounds and neutrals together past the first means of disconnect. And that 3.8 amps of current from that, and that's just one example, but that 3.8 amps of current on that ceiling fan not only is flowing on that intentionally grounded conductor, we've now introduced it onto these equipment grounding conductors, which is connected to the frame of this panel board, which we just introduced circulating currents onto the frame of that panel board, these raceways and so on. So it's vital that we separate or isolate our grounded conductors from our equipment grounding conductors once we get past this first means of disconnect. That would be fed with a feeder in that case, and to size a feeder, we would just base it on the calculated loads of that particular panel board or feeder panel board that we're talking about. We can use that 83% ampacity adjustment factor that we looked at a while ago if that feeder supplies power to the entire dwelling unit. Here's a photograph, a couple of photographs that I took a couple of years ago, and the local utility company is going to dictate where our service equipment is located. In other words, we have an electrical easement right here, and somewhere on this wall right here, we got to locate our service. And so in this case, and again, on the back side of this brick wall here is the kitchen or master bedroom or something. So the installer chose to run a feeder. Now, when we get to the final, we're going to have a disconnect sitting over the top of this, and we're going to have a meter base probably, right next to it. Utility company will provide power to that meter base. Will nipple over to this first means of disconnect, main disconnect, that will supply power to this feeder right here. And as you can see, in this case, they've used service entrance conductor cable. And this is the exact same cable right there. Here's one end of it, the end of one end, and the end of the exact same conductor. I took 2 photographs. They went all the way across the house and located a feeder panel board in the garage. And again, there's that bar I was talking about that the manufacturer will provide. I would suspect greatly that the label you would see on the inside of this cabinet would say suitable for use as service equipment. Because of this bar right here, I don't think it would say suitable for use only as service equipment. Because we are using this in a feeder panel board capacity, at some point we would remove that bar right there that ties the grounded conductors, intentionally grounded conductors, neutral conductors, to my equipment grounding conductors over here. And this is a 4-wire feeder. In other words, we have 2 hot conductors, we have a neutral conductor and an equipment grounding conductor. And the equipment grounding conductor from this feeder right here would, attach over here, and the intensely grounded conductor would attach over here with this bar removed. We would have a main bonding jumper right here attaching the equipment grounding conductors to this metal cabinet. And these grounded conductors would be floating or isolated from there's probably a piece of plastic or something. We can't see it real good in this photograph, but there's a piece of plastic or something that would isolate these conductors even from this metal cabinet once this bar from the manufacturer is removed. And again, that's the exact same feeder. We've already discussed this. I'm not going to spend a lot of time right here, but if that feeder supplies power to the entire dwelling unit, then yes, we can use the 83% adjustment factor that we saw back there at E3603.1 if it provides power to the entire dwelling unit like this one right here. For the 2020 NEC, 2021 IRC, that table that I talked about that we saw got removed in the 14 NEC, 15 IRC. It came back in the 17 NEC in the annex. It has made a triumphant return for the 2021 IRC, 2020 NEC. It's going to be located at, now you can, in other words, what this does, and this table is based on that 83% load calculation. You can do the 83% load calculation if you choose to, or just simply use these sizes that the table gives you. In other words, if you were to do the 83% load calculation, it would come out to be these exact same sizes 100% of the time. So I was not a fan of that table being removed from the code in the first place. And rightfully so, it has made a triumphant return for the next edition of the code. Located at E3603.1.1 in the National Electrical Code. It used to be located at 310.15B7. It will now be located at 310.12. Article 310 for the 2020 code cycle went through an extensive revision process, and hardly anything is in the same place. You know, and that happens from time to time in the code. You do a reorganization of a article to put common things in one location, making it easier on the user of the code to find stuff in the code. And that happened in the 2020 code. Required to provide overcurrent protection for feeders. That we've talked about that a lot already. Here's a couple of feeder panel boards with feeders coming from a disconnect like we saw on the outside of the house. Something similar to that right there. Here's a feeder panel board right here. That's a feeder right there. There's my intentionally grounded conductor, my neutral conductor, my two hot conductors, my phase conductors, and an equipment grounding conductor coming out of here and connecting down here to my equipment grounding conductor terminal bar. We talked about this already, that we have to separate or float our grounding conductors from our equipment grounding conductors when we get past this first means of disconnect. You know, again, these grounded conductors to our branch circuits coming out of here are going to be current carrying conductors, and we don't want to attach them. We don't want to introduce circulating currents onto the equipment grounding conductors past our first means of disconnect. Here's a typical panel board that you'll see at a dwelling unit, and notice that bar right there. This is being used as a feeder panel board in this situation, and that label right there, I guarantee you, probably says suitable for use as service equipment. Again, it would not say suitable for use only as service equipment, because the manufacturer has provided a means where we can remove this bar right here, which isolates these grounding conductors from these grounded conductors here. These are current carrying conductors over here past my first means of disconnect. Notice where my main bonding jumper is right here on the equipment grounding conductor side. That green screw right there screws right into the cabinet, bonding or grounding this metal cabinet right here. And with this plastic and all right here, keeping these intentionally grounded conductors, neutral conductors, floating or isolated from the equipment grounding conductors. All right, we talked quite a bit about our service right there. So let's move into another topic right here. Let's talk about our receptacle outlets and our spacing requirements for our receptacle outlets. This is one of those rules in the code that is kind of specific to a dwelling unit. My office right here that I'm sitting in today, in this office, we just got through remodeling this building. So it's basically a brand new building here. How many receptacles by code am I required to have in my office here? I'm not required to have any receptacles in this office, much less how far apart do they need to be spaced. But of course, now, for convenience sake, yes, I've got some receptacles in my office here, but those are just by choice. They're by the grace of the designer. You know, as the owners of this building, we demanded that there be, you know, receptacles in this office here. Well, that's not true at a dwelling unit. You don't have a choice at a dwelling unit. You're required to put a certain number of receptacle outlets in bedrooms and living rooms and places like that. And our spacing requirements here say that We can have no point along the wall line. And we're basically talking about living spaces or living wall space. So we'd be talking about here bedrooms, living rooms, dining rooms, dens, things like that. Now, we're not talking hallways. We're not talking foyers. We're not talking kitchens. We have our own spacing requirements for receptacles in kitchens that we'll look at here when we get through looking at this. But we can have no point on a wall where we are greater than 6 feet from a receptacle. In other words, what that says in plain English is we could go what? Up to 12 feet between two receptacles. In other words, what that means, guys, is if anywhere I chose to set a table with a lamp on it, between those two receptacles that are located 12 feet apart, anywhere between those two receptacles that I chose to put that table and lamp, I would be within 6 feet of one of those receptacles, right? That's what that rule means. And no point along the wall line. And a good rule of thumb right there is you measure on your backsplashes. Not your backsplash, your baseboards is basically where you would take those measurements from. If I have any wall that's 2 feet or wider, I have to have a receptacle to serve that particular wall. Why is that rule in the code? What are we trying to do here? What are we trying to eliminate here? We're trying to eliminate extension cords being run through doorways and under carpets and things like that. So any wall space that's 2 feet or wider, I have to have a receptacle for that particular wall. If we have any type of removable or sliding type panels, like a sliding glass door, something like that, we do not count that in our wall space. Now, the fixed part of that sliding glass door, yes, we count that, but we don't count the movable part. Any fixed room dividers, they are counted in our 6 foot measurement. A wrought iron railing that goes around the opening of a stairway up on the 2nd floor, that's wall space. That's a fixed room divider right there that we would have to count as wall space in our measurements. So we're looking overhead right here at this particular room. And we need to determine the number of receptacles required in this particular room. The best rule of thumb that I can give you here is you need to count the number of walls that you're dealing with, and you treat every wall completely, totally independent, separate from the other walls. What you do with one wall has no bearing on what you're going to do with the next wall. And in this particular case, there's one wall right there. That's a wall that's 2 feet or wider, so I have to have a receptacle to serve that wall. And then I have a wall right here that does go around a corner. That's a window right there, and would go to right there. So that would be considered one wall right there, and I can have no point from that point right there to that point right there where I am greater than 6 feet from a receptacle. So by code, I could go what, 12 feet from that door casing, 6 feet from that door casing, locate my first receptacle, 12 feet, 6 feet, and so on. Looks like I have a sliding glass door here with a fixed panel in the middle. That would be considered wall space if that's 2 feet or wider right there. So I would have to have a receptacle here. Now it's going to be extremely difficult, if not impossible, to put a receptacle in a glass panel, right? So what's probably going to be the solution right here? A
Floor receptacle.
A floor receptacle. And the code tells us that a floor receptacle can count as the required receptacle for spacing as long as it's located within 18 inches of the wall it's intended to serve. So here's another wall up here. So in this particular room, I've got 1, 2, 3, 4 walls I have to deal with. And whatever I do up here has no bearing on what I'm going to do over here. I can't tell you how many times when we used to meet in person, and particularly if I had some folks in the room that weren't that familiar with the electrical code, and I would say, how do you determine how many receptacles are needed in this room? And the answers I would get would just stun you. I mean, it was, well, you take the number of your children and divide it by 6, and I don't know where you're getting that stuff. You take every wall and you treat each wall individually, and any wall that's 2 feet or wider, yes, I have to have a receptacle. And then on these walls here, from that point right there to that point right there, I can have no point any greater than 6 feet from a receptacle. I get asked this question quite a bit. What about that space behind that door? Yes, that is considered wall space. I would actually take my measurement from right there to there and out. Some AHJs will start their wall spacing right there, and that's a misinterpretation of the code. The code does, the IRC and the NEC do count that as wall space. Interesting enough, the Canadian electrical code does not count that as wall space. So if you don't like that rule, I guess you can move to Canada. But no, but the NEC and the IRC both say, yes, that is wall space. I took this photograph several years ago, and it was because of the color of those walls and the color of the receptacles and switches there, it made a good photograph to say, yes, I can go up to 12 feet between those 2 receptacles and meet code. Now, in reality, what is that? Probably 8, 9 feet. But if I had to, I could go 12 feet between those 2 receptacles and still be code compliant. I could go up to 6 feet. Now, the code says that this measurement is taken from finished surface. Now, when do you have to enforce this? You're going to enforce it on the rough end where you got wires and 2x4s going everywhere. And if you wanted to get really, and no installer is going to take a chance like that. No installer is going to try to come exactly 6 feet off of that door. But if they did, you would take your measurement from the door casing, and you could go up to 6 feet before you had to locate your first receptacle. The code talks about things that can divide or separate wall space, one wall from another. And it talks about like a door or a doorway can be, in other words, on one side of the door is a wall. On the other side of the door, you got another wall that starts and so on. In other words, we don't count a door space or a door opening. We don't count fireplaces, and we don't count fixed cabinets. Now, for the 17 code, 17 NEC, 18 IRC, that language you see there in the yellow had to be added. Fixed cabinets that do not have countertop or work surfaces were the fixed cabinets that they were actually talking about. So something like this right here, where I've got a fixed cabinet that does not have countertop or work surface. Now, guys, I need you to know that that is a built-in, I drew this illustration, but it's hard to depict it. This is a built-in cabinet built by a trim carpenter. It's not a piece of furniture that I went and bought and stuck in that corner. That's not what we're talking about here. We're talking about fixed cabinets that do not have a countertop or work surface. Now, I have some fixed cabinets right here, but this has a countertop or a work surface. So technically I would take my wall space measurement from right there this way. I could come up to 6 feet from that point there before I had to locate my first receptacle and so on. And there, a lot of AHJs were saying, well, I'm going to start my next wall right here out. And that's not how the code actually reads. You would actually take your measurement from right here. You don't have to count this because that's fixed cabinets without a countertop or work surface. But my next wall space starts right there out. And I could be no point any further than 6 feet from this point right here, not this point right here. Fixed cabinets that do not have a countertop or work surface. So I'm not required by code to have receptacles along this. A lot of times you'll see a receptacle inside that cabinet and all, which is fine, but the code doesn't call for that. But this, I do have some fixed cabinets right here, but I have a countertop or work surface. So my wall space is going to start from right here out. No point any further than 6 feet from a receptacle and so on. Now, with this cabinets being built the way they are, you know, probably a study area or library or something, the homeowner's probably going to say, hey, put me a receptacle here and one here and one here and one here. I need a receptacle for a computer and a printer and so on and so forth. But that's going above the minimum standards of the NEC or the IRC. No point any further than 6 feet from a receptacle would be how you would enforce the receptacle requirements in a room like this right here. And, you know, a typical layout of a dwelling unit, and you see the receptacles and where they're located in a typical layout of your receptacles. Again, no point any further than 6 feet from a receptacle. In other words, I could come 6 feet from that end of that wall right there before I had to locate my first receptacle, and then I could go up to 12 feet between these two receptacles and so on. Don't have to count that fireplace, sliding glass panels right here or something like that. So yeah. That right there is considered wall space. It's fixed room dividers. So looks like I have a receptacle located right there. I could come up to what, 12 feet, you know, probably something like there to there before I had to locate that floor receptacle. And as long as that floor receptacle right there is located within 18 inches of the wall it's intended to serve, it can count as a required receptacle for spacing. Now we got to be careful right here because we have to watch this side over here too, because I can go no further than 6 feet from the end of this thing to this point right here for this floor receptacle to serve all of this railing area right here. Here's our rule that says that a floor receptacle can count as a required receptacle for spacing as long as that floor receptacle is located within 18 inches of the wall that it's intended to serve. Here's kind of an obscure rule that a lot of people miss. We have some rules in 21070A1 in the NEC, E3903.2 in the IRC that tells us that we have to have a lighting outlet in each habitable room, a wall switch controlled lighting outlet, a lighting outlet designed for lighting. That's, you know, a lighting outlet out in the middle of a bedroom or something like that. Well, there's an exception to that rule that says in lieu of a lighting outlet, I can use a switched receptacle for my lighting outlet. But we have to tie that rule, that exception, to our spacing requirements that we just got through talking about. So if we had a switched receptacle using our exception to a lighting outlet, and we were going to use a switched receptacle for our lighting outlet, if we switch the entire receptacle, the code sees that as a lighting outlet. It doesn't see it as a receptacle, and so we could not count that receptacle right there in our wall spacing requirements. Now, if you do what most people would do, run 3 conductors down here, break the tab off right here to where the bottom side of this receptacle is going to be hot all the time. The only side we're going to switch is the top side. The code does recognize that as part of our wall spacing requirements. We could use that receptacle in our wall spacing, but if we switch the entire receptacle, then the code again sees that as a lighting outlet, not a receptacle outlet. And we cannot use that in our wall spacing requirements as far as that no point any further than 6 feet from a receptacle or a wall 2 feet or wider or so on. All right, let's talk about our small appliance branch circuits and receptacles. These are the receptacles that you're going to see in your kitchen areas, kitchen, dining rooms, breakfast rooms, and so on. We have to have at least 2 small appliance branch circuits. They have to be rated. Wow. I just now noticed my clock. I didn't give y'all your second break, did I? We're almost up to lunch. Shoot. Y'all want to go ahead and break or just go to lunch? Anybody need? Huh?
Going to lunch as far as I'm concerned.
Okay, let's just keep going. And if you need a bathroom break, I apologize. I forgot to give us our second break. If you need to step away from your computer, be my guest. But we'll just roll till about 12 and take our lunch break here. But we have to have 2 small appliance branch circuits. They have to be rated at 20 amperes. In other words, what size conductors are we going to be looking at here? A minimum of 12 gauge copper. Those 2 20 amp small appliance branch circuits are required to serve receptacle outlets only in kitchens, pantries, breakfast rooms, dining rooms, seminar rooms, or areas. That right there that I just read, that first bullet point right there, is one of the most violated sections of the code that I see at dwelling units. I can't tell you how many times I see a lighting outlet, a switch and a light above a kitchen sink stuck onto a small appliance branch circuit. That's a code violation. Receptacle outlets only in kitchens, pantries, breakfast rooms, dining rooms, seminar rooms, or areas. Or sometimes you'll see a bar area of a kitchen open, to the den or something. In other words, on one side is the kitchen, on the other side of that bar area is the den. And of course, that's wall space on the other side of that bar area. And you're required to have a receptacle there to serve that den. And a lot of people will put that receptacle right there on the small appliance branch circuit, and that's code violation. Receptacle outlets only in kitchens, pantries, breakfast rooms, dining rooms, seminar rooms, or areas. And again, if I had to come up with a top 10 list of code violations that I see at dwelling units in my travels, boy, that would be up at the top. I see that violated over and over and over again.
By violated, Keith, you mean that it's they've got one branch circuit that feeds all of them?
That's a code violation. But what I'm talking about is a bedroom receptacle served by a small appliance branch circuit, even if you have your 2 or more. A DN receptacle served by a small appliance branch circuit. A switch and a light above the kitchen sink supplied by a small appliance branch circuit. All of that's a code violation. What does the code say right here? These 2 or more small appliance branch circuits are required to serve receptacle outlets only in kitchens, pantries, breakfast rooms, dining rooms, similar rooms or areas.
So by having that 20 amp in a bedroom,
It's
That
not
vi-
so much, it's not so much running a 20 amp small appliance branch circuit to the bedroom. It's on one side of the wall is the kitchen, on the other side of the wall is the bedroom. And you've got a receptacle sitting there facing into the bedroom. And it's so easy and convenient just to feed that from the small appliance branch circuit rather than run, 25, 30 more feet of wire over from a general lighting circuit and catch that bedroom receptacle outlet. Let's just stick it on the small appliance branch circuit, and that's a code violation. That's what I'm saying.
gotcha.
Again, kind of a obscure section of the code is our refrigeration equipment in a kitchen. The refrigerator is required by code to be supplied by one of the small appliance branch circuits. That's kind of the very end of that requirement right there. It tells us that refrigeration equipment has to be supplied by a small appliance branch circuit. An exception, though, lives right there that says that I can run a 15 amp circuit, 15 or 20 amp circuit to that area and supply a refrigerator. It actually says now any appliance. It used to just say refrigerator, but any appliance, and by exception, put it on its own individual circuit. But that's the exception, not the main rule. And again, a lot of people they read that to say, well, the code tells me I have to supply the refrigeration equipment with its own individual branch circuit, and that's not what the code says. That's by exception. The 2 or more small appliance branch circuits are not allowed to have other outlets, such as an outdoor receptacle, a bedroom receptacle, lighting outlets, and so on. Now, when it comes to our receptacles that serve a kitchen countertop, those are required to be supplied by a minimum of 2 small appliance branch circuits. In other words, what you couldn't do is run 2 small appliance branch circuits, but then use one of them and catch the receptacles in the dining room and nook, and then use the other one to catch all the receptacles in the kitchen. You met one code rule with the 2 small appliance branch circuits, but you violated another code rule by putting all of your kitchen countertop receptacles on one small appliance branch circuit. And they can go on to serve, some of those other similar areas like a nook or a pantry or a dining room or something like that. No small appliance can serve more than one kitchen. Today, boy, especially when you get into some of the higher end dwelling units, you'll see you'll have your main kitchen, but then in the back of the house, you'll have what people refer to as a mother-in-law suite. And you'll have an area back there that probably has its own entrance egress, from outdoors. And of course, they have their own bathroom back there, but they'll also have a area, they'll have a countertop there and a sink. And then they may even have a range top or something there. And that would be considered a kitchen. A kitchen is defined as an area with a sink and permanent provisions for food preparation and cooking. So we couldn't use the same small appliance branch circuits to serve our main kitchen and that mother-in-law kitchen as well. That mother-in-law kitchen would require its own 2 small appliance branch circuits. At a lot of the high-end dwelling units, man, I'm starting to see a kitchen located at the patio. You guys have probably seen that. And, you know, again, definition of a kitchen. If I have a sink out there at that patio area, and chances are pretty good, you again, with what I'm trying to describe, they'll probably have a sink out there. And if they have permanent provisions for food preparation and cooking, guess what you got yourself? You got yourself a kitchen, another kitchen, and that would require its own 2 small appliance branch circuits as well. And so we got to have at least 2 small appliance branch circuits. I could catch dining room receptacles, and then come over and catch the kitchen receptacles, the kitchen island, this one, and this one. I run another small appliance branch circuit and catch this one and this one and this one, and I've met code right here. Now, again, that refrigerator is required to be on one of these small appliance branch circuits unless I choose to employ the exception that says that I can run a dedicated 15 or 20 ampere branch circuit for a specific appliance such as a refrigerator. Now, what I can't do, if I choose to employ this exception right here and run this 15 or 20 amp branch circuit to catch this refrigerator, what I couldn't do is try to jump over and catch some lights or receptacles in the bedroom or something. This has to be a dedicated circuit, which means no other outlets. If I were to try to put that light and switch for a light above that kitchen sink on the small appliance branch circuit, that'd be a code violation. Very convenient. Boy, I could save a bunch of wire if I've got an outdoor receptacle right here. Let me just drop down with a couple of feet of wire and catch this outdoor receptacle rather than run its own branch circuit from a general lighting circuit and catch that. That'd be a code violation. That's what I was trying to say a while ago. That'd be a code violation to put anything other than kitchen, dining room, breakfast room, pantries on receptacle outlets only on your small appliance branch circuits.
Keith,
Yes, sir.
I usually see that that they actually sharing the 2 of them circuits either with the outlet for the behind the range for the clock, or the light, like you said, or the range hood, which is
there's a couple of exceptions that we're getting ready to look at that would permit that electric clock on the small appliance branch circuits, but just a outdoor receptacle like this, or that switch and light right here, that is a clear code violation of the code.
Yeah, I had a contractor trying to tell me, well, he had a bad habit of doing it. Well, I'm going to put it on GFCI. That's why I do that. And I was like, no, it needs to be on its own. You know what I mean? That's what I'm requiring the city.
Yeah. That contractor has just as much right to be wrong as the next person. And in this case, he is.
I have a question about the islands.
Okay.
I wrote it too. The islands, do they get to a certain size where they would require more than one receptacle?
Depending on which code you're enforcing. And I've got some slides coming up on that.
Oh, okay.
And so when we get to those and I don't answer your question, bring it back up. Okay.
Okay, thank you.
Here's that appliance exception that will allow you to put a 15 or 20 amp circuit for a dedicated appliance such as the refrigerator. Again, this used to apply only to the refrigerator, but under the 17 NEC 18 IRC, you can actually even use it for any appliance, dishwasher, something like that. Here's those 2 exceptions. no other outlets other than receptacle outlets only, kitchens, pantries, dining rooms, nooks, and so on, with 2 exceptions. And those 2 exceptions, if I have gas-fired appliances, now those gas-fired appliances are going to take a 120 volt circuit, correct? For clocks and timers, and I mean, they don't pull hardly anything, but they are going to require a 120 volt receptacle. The code gives us an exception to allow us to put that receptacle for a gas-fired appliance on one of the small appliance branch circuits. The second exception says we can feed a electrically powered clock. With that electrically powered clock in a kitchen, dining room, pantry, those same areas, by exception, I can put that on the small appliance branch circuit as well. When's the last time you saw an electrically powered clock? It's one of those rules in the code that just keeps coming forward. I think it kind of reminds everybody of grandma, and nobody has the heart to kill it. But so it's still in the code even today. It's been in the code for about 55 years. But those are the only 2 exceptions from on your small appliance branch circuits, is your gas-fired appliances and an electrically powered clock.
Yeah, the only clock I see is in the range. Normally, right now, usually on those ranges is the clock where they're trying to hook it up,
And
which
that
is
would,
okay on the clock.
yes. If that's part of a gas-fired appliance, then yes, that
Right.
can go on the small appliance circuit.
Yeah, the problem that I have is whenever they're trying to hook it up to a range hood or a lighting, stuff like that, or even outlets, even worse.
Code violation.
Yes.
As far as the location of our receptacles along the kitchen countertops, we can have no point any further than 24 inches from a receptacle. In other words, we can go 48 inches between 2 receptacles if the countertop's big enough. If we have a countertop that's 12 inches or wider, we have to have a receptacle to serve that particular countertop. On our islands and peninsulas, we have to take a measurement along the countertop itself. Now, guys, I'm talking 2017 NEC, 2018 IRC. And what I'm getting ready to explain here is relevant for those 2 codes. When we get to the next code, it's completely different. And I have some rules coming up on that. But for the 17 code, 18 IRC, you simply take a measurement on an island or a peninsula. Let me get to this. Yeah, this is easier to explain right here. No point along these base countertops can I be greater than 24 inches from a receptacle. In other words, I could go up to 48 inches between these 2 receptacles if I had to. Anywhere I chose to put a blender or a toaster or something in between these 2 receptacles, no matter where I put it, I would be within 24 inches of one of those receptacles. You agree? That's what that rule means. A lot of people will read that rule and say no point 24 inches. And they'll say I need a receptacle every 24 inches, and that's not what the code says. Code says no point along this backsplash, and that's another. You don't take your measurement from right there to right there. You take your measurements along that backsplash. Any countertop that's 12 inches or wider, I have to have a receptacle to serve that counter space right there. If that counter space right there was along this backsplash, I measured 11 7/8 of an inch. Would I need a receptacle there? Not per code. You might want one there, but you wouldn't be required to put one there per code unless it's 12 inches, 12 and a half, something like that. Then you would be required a receptacle. Now, when it comes to our islands and peninsulas, you're going to take a measurement. you're going to take a measurement from this perpendicular wall back here under the 17 code 18 IRC, a measurement right here this way and a measurement that way. And if you come up with a measurement of 24 inches or greater one way, 12 inches or greater the other way, the code says you need a receptacle. Now, to answer your question that you asked a while ago, I believe it was Carla, what if I took a measurement there under the 17 code, 17 NEC, 18 IRC? What if I took a measurement of this right here and it measured 8.5 feet this way, 8.5 feet by 24 inches this way, 8.5 feet this way, 24 inches this way? How many receptacles would I be required out there?
One.
That's it. Now, we got rules coming in the next edition of the code that says, wait a minute, maybe it's time that we have more than one receptacle for those large countertops like that. And we'll look at that here in just a second. But for this edition of the code, one receptacle would be required out there. Now, what if I had that 8.5 foot long peninsula, 24 inches wide, and I chose to put a range top in the middle, a sink or a range top or something? Now what I've done is broke up that counter space into two separate counter spaces. And so what I would do in that case is measure what I have left. And if I have 12 and 24 or greater on one side, 12 and 24 or greater on the other side, now I would need what? Two receptacles, for those two separate counter spaces there. And the exact same thing with an island. You take a measurement across that island, 24 inches or greater one way, 12 inches or greater the other way, you need a receptacle to serve that countertop. And guys, I cannot overemphasize this. When it comes time for you to determine how many receptacles are needed to serve the kitchen countertops, it is vitally critical that you count the number of countertops you're dealing with and treat every countertop completely, totally independent, separate from the other countertops. What you do with one countertop has no bearing on what you're going to do with the next. And in this case right here, I have one. Now, this one right here is going to come to the job site in one big long L shape. Trim carpenter is going to cut a hole for that sink right there, but physically, my two dogs would say that's still one countertop because they're still attached. But per the code, when you put that sink right there, as long as I don't have 12 inches of space behind this, and in reality, you might have what, an inch back there. So the code would look at that as a break in the counter space. So there's one countertop, there's two, there's three, there's 4, 5, 6 countertops that I have to deal with in this particular kitchen here. And you treat every countertop complete. Whatever I do with this countertop right here, that L-shaped countertop right there has no bearing on what I'm going to do over here. And again, people, when you ask them how many receptacles are needed, take the square footage of the house and divide it by the number of states in the United States. And I just have no idea where people are getting rules like that. They're just making rules up. No point any further than 24 inches from a receptacle, and any countertop that's 12 inches or wider on your base countertops. That's another thing. When it comes to your island countertops, your kitchen countertops, there's actually 3 types of countertops that you can encounter. What I call base countertops, in other words, the countertops that back up to a wall or something, those have rules completely separate from, that's where you get into your no point any further than 24 inches. Once you get to these islands and peninsulas, your 24-inch rule gets thrown out the door. It does not apply. You simply take a measurement across this way and that way, and if you come up with 24 inches or greater one way, 12 inches or greater the other way, you need a receptacle to serve that island or peninsula, and your base countertops is where your no point any further than 24-inch rule comes in. In order, now, the first thing I'm gonna do is take a measurement along this countertop here. And if I come up with 24 inches or greater one way, 12 inches or greater the other way, I need a receptacle to serve this countertop. Now, in order for that receptacle right there to serve that countertop, it has to be located within 12 inches of the countertop it's intended to serve. If you saw a receptacle right down here, it's probably there to serve this nook or something out here, not to serve this kitchen island here. Matter of fact, it would be a code violation for that one to try to serve this island, because again, in order for a receptacle to serve this island right here, this countertop, it has to be located within 12 inches of the countertop it's intended to serve. And you see these base countertops back here, from the end of that counter space, 24 inches, no greater than 24 inches, 48 inches, 24 inches from that receptacle to the edge of that sink, 24 inches, 24 inches, 24 inches, and so on.
Keith,
Yes, sir.
Keith, also on what you mentioned on this island, shouldn't that apply also the 6 inches overhang max along with the 12 inches in order to
Yes.
be applied?
Yes, yes.
Okay.
And you're stealing my thunder. We're gonna get to
Okay.
that.
So
All right.
Yes, sir. No, no, no. That would be one counter space right there. From the edge of that counter space to the edge of that sink would be one counter space. Okay.
Keith, I've been getting a lot of islands they're called fountains. So the edges go over, like the top goes over. What's a good approach for receptacles to meet the code? Because
What do you mean? What do you mean?
it's difficult to put a receptacle on the end.
I don't understand what
So
you mean by over. What do you mean?
So they're called fountain tops. So the top of the island actually curves over and goes down, sometimes to the floor.
I've never encountered that, so I'm not sure. But
Thank you, waterfall. They're called waterfalls. I call them a pain.
yeah, I don't think, if I'm the authority having jurisdiction, and that's all I can do is make a determination as the AHJ when you encounter something unusual like that. When we start falling off the edge of that cabinet with this waterfall countertop or whatever, I would not consider that part that's vertical there
I try to work.
workable counter space. I would take my measurement along that top, and I would need a receptacle somewhere to serve that counter space that could not be located under an overhang of greater than 6 inches that we'll talk about here in just a second.
Right. So what I try to do is get it to the very edge.
Okay.
They don't have that 6 inch. Generally, they're pretty slim on the sides.
If in this particular photograph right here, if this countertop just kept on flowing this way, that receptacle right there would satisfy this requirement.
Okay, because
It
that's what
doesn't
I've
have to be located close to this
Right.
edge or anything like that.
because that's what I've been doing. I just wanted to make sure that my approach
Yeah.
fell within the code. Thank you.
24 inches. 24 inches. Now, is that 24 inches right there and right there? No. I'm talking minimums, maximums here. I could go up to 24 inches, 24 inches, 24 inches, 48 inches, right there, and 24 inches, and be code compliant. if you encounter a appliance garage like this right here, a lot of times you'll see a receptacle inside that appliance garage. That receptacle right there cannot count as the required receptacle to serve this countertop right here. That receptacle right there, again, as long as you are no further than 24 inches to over here, then that receptacle right there could serve this countertop. But that one right there cannot be the required receptacle to serve this countertop when it's located in an appliance garage like that, or like this right here. And so I would actually take my measurement from right there out, no point any further than 24 inches, and from right there out, no further than 24 inches. There's two figures that shows up in the IRC and the NEC, and it talks about the space behind something that has the potential to break up a counter space, like a range or a sink or something. And one of the illustrations deals with a straight countertop, and the other one deals with a corner mounted countertop. And this is actually where you get to these illustrations is actually found in an exception. The main rule here is that rule that says no point any further than 24 inches from a receptacle. And then you have an exception that says if you can meet the requirements of these figures, then no receptacles required. And then once you get to this figure, it says, again, you got one for a corner mounted, another one for a straight. We'll look at the straight in just a second. But it says if that X right there, in other words, I'm going to take a measurement from whatever has the potential to break up the counter space. In this case, a range top. I'm going to take a measurement from right there to that point. And if that X right there is less than 18 inches, then I don't have to have a receptacle from right here to right there. In other words, I don't have to, in other words, the code would see this as a break in the counter space. Now, in reverse, the code doesn't say this, but what it actually refers to is if that X is 18 or greater, then the code would see this as one big countertop space with no break in the countertop and no point any further than 24 inches from that point right there to that point right there. In other words, a receptacle is going to land back here somewhere. Again, the key is that measurement right there. If that's less than 18 inches, then no receptacle would be required from right there to right there. Same thing with a straight countertop, different dimension. I take a measurement from whatever has the potential to break up the counter space. And if that X right there is less than 12 inches, then the code says that this is a break in the counter space. I don't have to have a receptacle right here, but I would start my measurement from right there out and right there out. Now, subsequently, if that X is 12 or greater, then the code would see that as one big counter space with no break in the counter space. And I could have no point from right there to right there where I was greater than 24 inches from a receptacle. So in something like this, real world, you've got a sink here mounted in a corner. And I'm gonna draw these imaginary lines right here. And then I'm going to take a measurement from the sink right here to that point right there. And if that's less than 18 inches right there, then I do not have to have a receptacle from right there to right there. And I would start my countertop measurement from right there out. No point any further than 24 inches from that point right there out. From right there out. Now, if that measurement right there is 18 or greater, then again, the code would see this as one big countertop space, and you'd probably have a receptacle have to land back there somewhere. Doesn't look like it'd be very usable to me, but you know, that's what we get into with those illustrations. So we're going to take a measurement. We've got an island right here and I've got a sink. So I'm going to take a measurement from the back of that sink to the edge of that countertop right there. And if that's less than 12, then I've got 2 separate countertops. But if it's greater than 12 inches, then the code, even with that sink right there, the code would see this as 1 countertop. And under the 17 code, 18 IRC, I would need 1 receptacle to serve this entire countertop right here. That has changed, that we'll look at here in just a second. Gosh, we are right up against 12 o'clock. Why don't we go ahead and take our lunch break? And when we come back from lunch, and we'll come back at 1 o'clock. Do y'all want to take a full hour? I mean, it's up to y'all. We got to go till 4 o'clock this afternoon, 4 o'clock Central. If you want to take a little shorter lunch, we can get out a little bit earlier, but it's up to y'all. Doesn't matter to me. I'm here till 4.
The 1 hour lunch break provides me with a little time to catch up on
Okay.
emails and such at work.
Okay.
I don't know how
All right.
everybody else feels.
All right. I'll see you guys back here at 1 o'clock, 1 o'clock Central, and 1 hour from now. Okay. Have a good lunch.
Thank you, sir.